Hello, this is Kelly Cline. I teach at Carroll College up in Helena, Montana, and I'm telling you about our project, Using Clickers to Address Misconceptions and Promote Discussions in Statistics. So this is all about clicker questions where we present a multiple choice question to the class, give the students a few minutes to consider and discuss it in small groups with their peers. Everybody votes and then we lead a class-wide discussion on the results. So, how do students vote? Well, we often use clickers. These days, student phones and laptops can be used for voting, but I don't want to tell you about the technology. I'm interested in the pedagogy. Why do we do this? We do this because it gets students engaged, actively involved in the lesson, figuring things out, talking to their peers about important issues, understanding things. That is why we do this. But the key to make all of this work is to find really good multiple choice questions that stimulate rich, engaging, energetic discussions where the students are involved in things. We find there are a lot of questions that generate almost no discussion at all, and we find it very hard to tell in advance how a class is going to react to a given question. Is it going to work? Who knows? Our strategy is what we do is we record the percentage of the class voting on each option of a question. And when we do this several times over several iterations, several different classes, we find that the pattern can be really, really useful in lesson planning for the future. So in this study, we recorded the percentage of the class voting on every question used in 19 sections of introductory statistics taught by 3 instructors at 2 institutions over the course of 9 years. So our evaluation of the discussions was qualitative in nature. We found, first of all, that questions where a strong majority regularly voted correctly rarely generated much discussion because people knew what the right answer was. On the other hand, there were other voting patterns that often indicated really good discussions. For instance, misconception and common error questions where usually a large majority would vote for a specific wrong answer. Students would be surprised and intrigued that the majority was wrong. So how do we pick out these questions? Well, what we did was we identified what's the most popular incorrect answer, found the average voting for that over all the different classes, and then we could rank and pick out the best misconception, common error questions. So here was the very best one in our whole study, where we've got a store manager conducting an experiment varying the width of a toothpaste advertisement display from 3 to 6 feet. Here's the regression line. We say, what is the projected number of tubes sold per day for a display width of 12 feet? And most students, look at these results, 9 votes with an average of 79% vote that, hey, it's 140. But of course, the right answer is it would be unwise to use a regression line outside of our data range all the way to 12 feet. Great question. An important, very common error that this question allows us to discuss and deal with in class very effectively. As a general principle, we found that questions are going to get rich and engaging discussion when there are several different plausible options. So in order to identify those where we have a flat, broad distribution of votes, we looked for places where the plurality winner percentage was relatively low, rank the questions based on that, and here was one of our very best. So in this question, we say, what's the fundamental concept underlying statistical inference? And the right answer is B. Well, through the examination of sample data, we can derive appropriate conclusions about the population from which the data were drawn. Lots of confusion about this. This is one of these, we found a lot of these good discussion questions are these kind of forest rather than trees sort of questions. Let's ask the general principles without numbers and what are we really trying to do here? Great discussion. Great, interesting issues come up with students trying to figure out, parse through these different answers, figure them out. Very useful stuff. So here's our website. We currently have 206 questions for introductory statistics, freely available, download it anytime you like. If you'd like past voting statistics and a LaTeX file through these questions, just send me an email and I'm happy to provide them to you. In general, in this study, what we found is that classroom voting with clickers was an effective way, very good at promoting peer instruction and active learning. And we found that recording the percentage of the class voting for different options on these questions allowed us to pick through and find the best questions. So when I'm doing a lesson plan, I know I don't have a bunch of clunkers in there. I'm going to have really good, engaging questions because I know what's happened in the past. When we do end of semester surveys, we find that the results are overwhelmingly positive. Strong majority of students say they enjoy learning in this way because it's more fun to be figuring and talking and working things out than watching somebody else do statistics. So good stuff. If you have any questions about this or any comments, please feel free to post them up or send me an email. I'm happy to tell you more about our study and what we've been doing. Thank you.